Crawl on back here, Yuri. This is take 2. We just did a great video. Yuri, I mean, he was funny. He talked. I don't know if he's going to talk again. Oh, the video didn't record. So round 2 for rocks. Where's your note, buddy? Where's your note? So, who writes upside? Come on, Yuri. Who writes upside down? Rocks. Those are my one way to kind of remember the 3 different types of rocks, what you're looking for. It's so sad. I forgot my rocks at school. I didn't bring all my rocks home with me. Can't go back to school now. So, Yuri's sad too. He's trembling. Can't show you the actual real rocks. Got some pictures, old questions that we'll go through, trying to keep the 2 concepts separate. So we're going through rock content. There's going to be a whole separate section of videos for reference table skills, which a lot of this rock stuff comes from. But we'll do our best just to go through the content things. Identifying the 3 types of rocks, okay? So that's super important. What are the 3 types? You've got igneous, which is interlocking. Whoa! How cool is that? A volcano. So igneous rocks come from volcanoes. You've got sedimentary rocks. That's what Yuri was, a sedimentary rock. I saved him from a sedimentary rock. He's a fossil. He was in the ocean. He lived in the ocean. That's where most sedimentary rocks are made. Metamorphic rocks. I love the mountains. So metamorphic rocks are mainly what you find in the mountains. Igneous too, but metamorphic, mountain. Try to go with some of those ways to remember things. Igneous, I, interlocking crystals. The other ways that you can identify it. What are you worried about? No, I'm not going to let you near a volcano. Fossils and volcanoes, fossils and igneous rocks, they don't go together. He's whispering in my ear, he's afraid. It's okay. So, igneous, interlocking crystals. So if you look at these 3 things, you got to have these 3 memorized, okay? Interlocking crystals, glassy texture, or vesicular, air bubbles. So volcanoes, or if the rock is melted inside the earth, those 3 textures are the 3 things you can see with your eyes to know that it's an igneous rock. So you got to have those 3 memorized, and if you see one of those 3, it's igneous. Sedimentary, Yuri's a lot happier about that one. Only rocks that'll have fossils, okay? So if you see fossils, sedimentary rock. If you see stuck together, like clastic, that's called. So clastic is when you have particles that are stuck together. That's a sedimentary rock. And layers is one, but we're not going to even put it on the screen. Don't want you to use layers. Layers can get confused with metamorphic rocks. We want to keep things simple. Yuri's afraid again. Metamorphic rocks, messed up texture. Yuri does not like metamorphic rocks. He's afraid of, fossils are afraid of metamorphic rocks because when you take another rock and you squeeze it and you put it under a lot of pressure, it destroys fossils. And Yuri, I'm not going to let you get destroyed. You're going to be here. I've got a few more videos to make. So, metamorphic rocks, you're going to see some sort of distortions or messed up texture. Usually that's a foliation, or more specifically banding, shows up the nicest and it's the easiest, and it's probably the most asked about on the test. So we'll just go through some different questions. Not using our reference table for these ones. We'll probably go over some of these same questions again during the ESRT videos. I can't even rhyme outside of school. I don't know. Got no jokes, got no rhymes. Let's just get to these questions. All right, so first, just a diagram, not a question, but I like this diagram a lot because it shows all 3 types of rocks, and it shows where some of the rocks can get made. So you've got your sedimentary rocks right here. Those are just basically different size particles. So if you take sand and you cement it together, you got sandstone, all of these different rocks are made in the ocean, okay? But each of these rocks get metamorphosed. So if you take the tectonic plates, which we're still going to cover, if those 2 plates are colliding, you create tons of heat and pressure. So limestone gets squeezed and cooked and turns into marble. Dolostone also turns into marble, okay? Now you don't have to memorize these things because they're in your ESRT, and that's another video that you'll get from me later on. Sandstone turns into quartzite, so sedimentary rocks get squeezed. This is called regional metamorphism. They turn into new rocks. Now you also have, if it gets squeezed enough, let's change this color here to a little bit of red. If it gets heated up enough, it's going to melt. And all of this stuff was metamorphic rock that just got too hot and it melted, and now you have melted rock, igneous rock once it cools down, okay? And sometimes that igneous rock will come right out here and you'll get different textures in the igneous rock, but all of them are melted, okay? So you get your three types of rock. Your igneous, which are usually the core of a mountain because it gets so hot that it melts those rocks. Many mountains are made of metamorphic rocks, and then you have sedimentary rocks. So those are all three in one diagram. Here is another diagram that shows the different textures of rocks and just a few real-life pictures of them, but instantly I'm going to see, now I don't use this one as an option, layers, okay? So if you look at the side of this rock, this is a layer. And I know it's a layer because it goes all the way through a rock, all the way around. I'm just very hesitant to have you use layers because there's always another one you can use. So just like those things down there, you've got clastic stuff stuck together. If I see this texture, I know that there's little particles there. What I would do is I would use my fingernail and just try to scratch it, and I can kind of feel that sandiness, that grittiness. That's a sedimentary rock. This is much easier. You see these particles stuck together, sedimentary rock stuck together. And then just how cool is this? You get all these little crinoids. So crinoids are these little things that used to live in the bottom of the ocean. And that's the kind of the cross-section view of this stem-looking thing. But basically, it's a fossil. If you see rocks that have fossils, seashells, sedimentary. So here's another diagram that would show different igneous features, magma, lava. You don't have to know all of these terms like a laccolith and batholith and all that stuff. Sometimes they show up on a test. Just recognize that it is igneous. And if we look over here, you can see these are different interlocking crystals. Okay, so interlocking crystals, igneous. Also, I should have thrown a picture or two up there. Vesicular is air bubbles, gas bubbles like pumice, or glassy texture, obsidian. And those two are usually really easy for people to identify. So those are your three things that'll tell you you've got an igneous rock in your hand. And then metamorphic rock, mainly you're going to see banding, which is a type of foliation. Those are distortions. This used to be conglomerate, but you can see the pebbles all got distorted with my terrible tracing skills. So that's an igneous metaconglomerate. Nope, not igneous. That's a metamorphic metaconglomerate. Okay, so picture here, it tells you that it's got pebbles cemented together. Okay, so we don't even need to answer this question actually, but this is just to show you a type of conglomerate that would show up on the test. But if we were going to answer this question, the pebbles are older than the cement and the conglomerate. The pebbles had to be there first. Another one that shows, I mainly picked out these pictures to show you the different examples of types of rocks that you'll see, but you've got a conglomerate. And then it gets metamorphosed. This is really a reference table question, but I really like to show you, this is the metaconglomerate, so you get the metamorphic rock here, and this is the original, this is the parent rock, which was started off as sedimentary here. All right, so you've got another metamorphic rock. It tells you it's metamorphic, and you can see that banding, that distortion, okay? So that would be choice A. So, what diagram represents the sample of the metamorphic rock? This is where these 6 textures come in. And so if you're looking at it, hopefully you can pick out the metamorphic right away, but it's even better if you can just identify which type of rock each is, okay? So I've got my 2 sedimentary rocks. Those are things stuck together. And I've got my igneous rock. You can see those interlocking crystals. And then my metamorphic rock here, because I can see that distortion, that banding. This is a nice picture, not nice, like Nice. Get it? It's a nice picture. Never mind. So this is igneous, interlocking crystals. And you can see as these crystals are starting to form, when the magma's cooling down, they all fit together like pieces of a puzzle. So they're not stuck together. They actually grew together and they fit completely together. So the only igneous rock on here, which you might not know without your ESRT, but I happen to have mine in front of me, gabbro. That's the only interlocking igneous rock. Another ESRT question. You can use that rock cycle chart, but we're not focused on the ESRT. Really just wanted to show you the igneous rocks right here. Okay, interlocking crystals, another way that you could see the interlocking crystal. My daughter's obviously super excited about igneous rocks. We can hear her screaming back there. In the metamorphic rock, you get those same exact minerals like this, and it just gets squeezed and distorted and turned into a whole different arrangement, a different alignment. Again, you can see I'm picking these pictures so you can hopefully get different exposures to different drawings and diagrams for the different types of rocks. So mainly, yes, you need to know which one formed from lava directly at the surface. Your ESRT will help you with that, but number one, you want to be able to tell which type of rock is which. So when you look at this, what do you think? Pebbles cemented, stuck together, sedimentary. Gas pockets in glass, you've got a double. Gas pockets is called vesicular. Glass is glass, igneous. Mica crystals and so foliation right there is the key with some metamorphic. And then large intergrown, interlocking crystals is igneous. So definitely just practicing which of those 6 characteristics that keep popping up on the screen go with which rock. It's another one. It tells you it's igneous. It tells you the minerals that are in it. You would need your ESRT to answer this question, okay? But this is what an igneous interlocking, it kind of looks like that salt and pepper texture quite a bit. And if you did get out your ESRT, because you did learn how to use it this year, that would be granite. But we'll practice that in a separate video. 2 more good questions, okay? So we have different metamorphic rocks, and they're both showing the same texture here, okay? So you've got that banding foliated texture here, and you can see in the microscopic view, it's all the mineral alignment, okay? So those minerals get into a line that's a metamorphic, and the answers to these 2 questions don't really matter without your reference table. Just recognizing that you're seeing a metamorphic rock. Oh, that was the end. So, again, I've got nothing funny to say. Another note from me. I don't get it. Wait a second. Is that a piece of nice? Is that nice, Yuri? It is, isn't it? Nice fit. Thanks, buddy. I like the drawing too. It looks like a piece of nice that maybe came from the Adirondacks and was deposited in New York State by glaciers. You see how that's nice and flat on the bottom? Side note, not from this video at all, but always good little extra piece of knowledge. Remember, the glaciers is the rocks got scraped from the north. They got deposited in Rome, in our area. A lot of the rocks from northern New York and Canada, and they're nice and flat on the bottom, and sometimes they'll even show little scrapes on the bottom, slicking sides. That's great. You tied in a couple different concepts and you made a funny joke. Nice joke.